Hi, this is Mr. Ward, and I'm going to be talking about the zero product property. Now, you actually already know the zero product property. You just may not know it by name, but here is the basic idea. If I have two things that are multiplied and they equal zero, or any number of things multiplied or even divided by each other and they equal zero, then at least one of the factors has to be equal to zero. Okay, so not the divisors, because you can't divide by zero, but either v has to be zero in this expression, v times w equals zero, or w has to be zero. Either one of them, or both of them could be zero as well. So v equals zero, or w equals zero. One of those, at least one of those, if not both of those, is equal to zero. And that is the basic idea of the zero product property. If a product is zero, then at least one of its factors is zero. So we can use this to figure out some key things for polynomials. And the reason that, and the key thing that it allows us to find is x-intercepts, because x-intercepts are on a place that is literally the line y equals zero. You see when I type in y equals zero, it made a line on the x-axis. I'll even make that a little thicker so you can see. There we have a line on the x-axis. Okay. Now I'm going to shrinky-dink this a little bit because it's a little too big right now for me to do things like zoom in and out. Now, since we are saying y equals zero, then if we wanted to find the x-intercepts for, say, x squared plus 5x plus 6, then we could say that that whole function equals zero. We're basically taking y and we're replacing it with zero, because if y is zero, we're on the x-axis, because y equals zero is the x-axis. So what's really useful to do with a function like this is to factor it. If we can factor it, we can easily find the x-intercept. So I'm going to say x squared plus 5x plus 6, but I'm going to say it as a factored form. I'm going to take 6, break it into two factors that add up to 5. So x plus 2 times x plus 3 factors nicely to make that function. And if I say that equals 0, then what I need to do is figure out what x value would make this factor or this factor equal to 0. Now these whole things, x plus 2 is a factor and x plus 3 is a factor. If I can turn either one of those into 0, then I will have an x-intercept. Now Desmos is already handing it to us, but let's see how we would do that. So what would make x plus 2 equal 0? Well, this is a one-step problem. We can just subtract 2 from both sides, and we end up with x equals -2. So x equals -2. You'll notice here that it is the opposite of the plus 2 there. And that makes some sense. If I had -2 here, plus 2, that would be 0. And then 0 times whatever x plus 3 is. Doesn't matter that x plus 3 is not 0. It's multiplied times 0. So that -2 plus 3 doesn't matter. It's a 1. 1 times 0 is 0. Okay, now I'm going to put the x's back in, and I have x plus 2. I could also solve for x plus 3 equals 0. And it's a one-step equation. I get rid of addition by subtracting. I subtract 3 from both sides, and x is left at x equals -3. And once again, -3, if x was -3 here, -3 plus 3 would be 0. X is also going to be -3 here if I'm using that as the input, but it doesn't matter that that's -1, because this is 0. Okay, so this is the basics of the zero product property. Now I'm going to take care of another idea. So maybe we have something more complicated. Maybe we have a function that's 8x minus 9 times 7x plus 4. We'll make it 7x plus 2. Okay, equals y. So that's a factored polynomial. It's a quadratic because it's got two linear factors. And what I want to do to figure out what the x-intercepts are is I want to say y equals 0. So if y equals 0, I literally am on the x-axis because I am the x-axis. So what I want to do is find out what x values would make either one of these factors 0. Again, the theme is if you have a product of 0, one of your factors had to be 0. So to make that work, make this true, either 8x plus 9 is 0 or 7x plus 2 is 0. Now, it's not as simple in this case as like if I had x plus 11 times x minus 4 equals 0. In this case, x could be negative 11 because negative 11 plus 11 would be 0. And x could be 4 because 4 minus 4 would be 0. So I'd have x-intercepts at negative 11, 0, and 4, 0. And there I'd be my x-intercepts right there. I'll label them like that nicely. Okay, so I'm going to take those away now, and we're going to go to the slightly more complicated one. So these are easy to see because x is simple. It's just an x. But here we got an 8x minus 9. So there's something multiplied times that. But there's a simple method to dealing with this. All I have to do is set any one of my factors equal to 0. Because if I can turn that into 0, it will make the product 0. Because any factor that is 0 will make the product 0. So now I've got an equation that's just a two-step equation to solve. I'm going to use my two-step stuff from way back in the beginning of the year. So I want to first get rid of subtraction. So I'm going to do that by adding. So I add 9 to both sides. Okay. And that becomes a 9 over here, and negative minus 9 plus 9 is nothing. Now I'm down to a one-step equation, and I'm just going to divide both sides by 8 to get rid of multiplication. And so 8 over 8 is just 1, so x is 9/8. So that's one of my solutions, one of my roots, one of my zeros, one of my x-intercepts were all words for the same thing. So I'm just going to plot that as an x-intercept. Okay. Now, Desmos will, of course, turn it into a decimal. Okay. Now, I'm going to do the same thing with the other factor. So the other factor, I'm going to make it equal to 0 because what I'm really doing is I'm finding the x-intercepts of the factors. The x-intercept of the factor will make the factor 0. So I'm going to say 7x plus 2. It's a two-step equation. My first step is to get rid of plus 2. So I'm going to subtract 2 from both sides. And on the right side, that's just a minus 2. On the left side, the plus 2 minus 2 becomes a 0. I'm left with 7x equals negative 2. Now I'm going to divide both sides by 7 because I've got multiplication by 7. So divide by 7. And now 7 over 7 is 1. I don't care about 7 over 7. And so my other x-intercept is negative 2/7, which is this crazy long 6-digit repeating decimal. So I'm going to go ahead and do it as a fraction because it has time to write forever. Okay, negative 2/7. 0 is my other x-intercept. And so if I go ahead and put a y back in, then we have the parabola going through those x-intercepts, and we are good. Okay, so you heard me talk about some vocabulary. So here's some vocabulary. Vocabulary. Okay, the vocabulary. So you know, hopefully, that an x-intercept is where a line or graph goes through the x-axis. Okay, There are other words for an x-intercept, though, particularly when we think about polynomials and other functions. So also, we can call an x-intercept a zero. And it's called a zero because literally the function becomes equal to zero there. We can also call it a solution because when we find the x-intercepts to a polynomial or many other types of functions, the solution, finding the x-intercepts gives us solutions to problems we're actually trying to solve in reality with the polynomial. And because polynomials can also be thought of as functions that are where x is to a power, we can get rid of powers by getting roots. So we can also think of it as a root. So those are three other words for x-intercept: a zero, a solution, or a root. And so keep that in your pocket because those are going to be words that are going to come up over and over again. A really common one is to call things zeros. You will hear them all of these in the coming years. Okay. Now, I'm going to tie this up. The basic idea, if I have x minus, let's say I'm going to use letters this time, x minus q times x plus p times x minus k times x plus v. Stretch this out so you can see the whole thing. And if I want that product to equal 0, then what I need to do is I need to identify what x values would make any one of these factors 0. Now, I haven't given you numbers, so I'm just giving you letters. But here's the thing. Q minus q would be 0. K minus k would be 0. So a couple of our x-intercepts would be, let me get rid of that stuff because I didn't actually want that to happen. A couple of my intercepts would be x equals q and x equals p. Those are two x-intercepts. But I'm sorry, not p, k. So x equals q and x equals k because q minus q is 0 and k minus k would be 0. I could also say x is negative p because negative p plus p would equal 0. And I can say x equals negative v because negative v plus v would be 0. So you're looking for what would you add or subtract to the other term to make it 0. Now, it's a little more complicated if there's some sort of coefficient in front of x, but it's totally doable. You just would take it out. And let's say it was 3x plus v. I would just take that out and I would say that equals 0 and I would solve it. So I would subtract v from both sides. So v goes away on the left. There's nothing wrong with doing it with this letters. This is letters, in fact, just less calculation. And then I'm going to divide both sides by 3. And the 3 over 3 is 1. So x would be negative v over 3. All right, I hope that was helpful. The basic idea of all of this is that if a product is 0, then at least one of its factors has to be 0. So if I have v times w equals 0, either v is 0 or w is 0. A few of you have referred to opposites. I think that maybe you're thinking of addition in that case. V plus w would have to be opposites for the solution, for adding them to be 0. But we're talking about multiplication. So multiplication times 0 will make something equal to 0. Okay. And I'll just review quickly the vocabulary. We also call the x-intercepts zeros, solutions, and roots. If it's more complicated, you simply take the factor out and you make it equal to 0, just like I did. So Say that equals 0, and you solve for x using basic equation solving tools. And whatever makes this equal to 0, whatever x value you get, is an x-intercept. All right, that's a good place to stop.